exciting installment of Video Notes with Miss Lawrence. Today's video notes are over section 1.6, Properties of Numbers. We're going to look through a few properties that are going to be really important for us both this year, going through algebra, and next year in geometry. So we're going to start with our properties of equality. So the first property of equality we have is the reflexive property. So the reflexive property says that any quantity is equal to itself. So for any number A is equal to A. So examples of this is that 5 is equal to 5, or if we think about something more complex, 4 plus 7 is equal to 4 plus 7. And in that one, the order is very important. It has to stay in the same order. And the reason is because there's another property that deals with changing the order. So that property is the symmetric property. So the symmetric property says that if one quantity equals the second quantity, then the second quantity equals the first. So in symbols, we have if A equals B, then B equals A. Also, we have that if 8 equals 2 plus 6, then 2 plus 6 equals 8. And we could also just flip around the 2 plus 6 and say 2 plus 6 equals 6 plus 2. So that's the symmetric property. Our next property of equality is the transitive property. So in words, the transitive property sounds or looks kind of complicated, but it's really not bad. So if one quantity equals a second quantity, and the second quantity equals a third quantity, then the first quantity is also equal to the third. So it's a lot of words to say that if A equals B and B equals C, then A will also equal C. So look at the example to try to help you figure this one out. So we're going to start the example with 6 plus 9 equals 3 plus 12. So if we know that 6 plus 9 equals 3 plus 12, and we know that 3 plus 12 equals 15, then we can also say that 6 plus 9 equals 15. So all of these have the same sum, they all equal 15, and we just show that using the transitive property. In this first set, our next one is the substitution property, which says that a quantity can be substituted for its equal in any expression. So if A equals B, then anytime you see an A, you can replace it with a B. So the most common way that we use the substitution property is when we have examples that say n equals 11, and then ask us to substitute it in to simplify an expression. So if n equals 11, then 4 times n would be 4 times 11, or 44. So our first little pop-up question comes next. So this property says we come to our first quiz question. So, which property is shown? This question says if apple equals fruit and fruit equals yum, then apple equals yum. So which property does this show? So take a second to think about it. Then we'll come to our answer, and the answer is the transitive property. So the transitive property said if A equals B and B equals C, then A equals C. So since apple is fruit and fruit is yum, apple is also yum. Our next set of properties are going to be addition properties. So that means that they work for addition. Our first addition property is the additive identity. And something important in the additive identity is the identity. Our next category of properties are the addition properties. The first one of these is the additive identity. So the important word in here is the identity. So identity means itself. So additive identity means we want to add something to a number to get back itself. So for any number a, the sum of a and 0 is a. A plus 0 is 0 plus a, and all of that gives you the same sum of the number that you started with. So 2 plus 0 is 2. 0 plus 2 is 2. Anytime you take a number and you add 0 to it, you get itself. The second property of addition is your additive inverse. So the additive inverse says a number and its opposite are additive inverses of each other. So by opposite, we mean the opposite sign. So we have a number and its opposite, and whenever we add them together, we get this special number 0 back. So 3 and its opposite, negative 3, are additive inverses. Whenever we add them together, we get 0. Negative 4 and its opposite, positive 4, are additive inverses. We add them together and we get 0. So now, let's try our next property quiz. So which property is shown? We have this really large number. That would be 123,456,789 plus 0 equals the same number. So which property is shown here? If you said the additive identity, you are correct. So that's just a number plus 0, and we get itself back, so that's an identity. Now let's move on to our multiplication properties. So we have 3 multiplication properties, starting with the multiplicative identity. So that identity word comes back. So that means that we're going to multiply by some number to get the same number back. So for any number, the product of the number and 1 is always going to be that number. So 1 is your multiplicative inverse. Any number times 1 is going to be itself. So our example here is that 14 times 1 is 14. Our next multiplication property is the multiplicative property of 0. So for any number, when you multiply it by 0, you're always going to get 0. So in symbols, a times 0 is 0. In an example, 9 times 0 is 0. So this is called the multiplicative property of 0. It works for any number. If you multiply it by 0, you will get 0. Our last multiplication property is the multiplicative inverse. So this deals with fractions. For every number a over b, and the important thing is that a and b cannot be 0. So we can have 1 over 2, we can have 7 over 9, we can have anything, but a and b can't be 0. So for any number, there is exactly one number where the product of those two will be 1. So this is what we call the reciprocal, the multiplicative inverse. So if we have a over b, the reciprocal of that will be b over a, and if I multiply those together, notice that we have an a on top and bottom and a b on the top and the bottom. So those will give us 1. So in an example, here we have 4/5 and its reciprocal 5/4. So 4 times 5 is 20, 5 times 4 is 20, and anytime you have a number divided by itself, you're going to get 1. So that's the multiplicative inverse. So here's our next property quiz. So which property is shown here? We have 2 fractions, and the product of those fractions is 1. If you said the multiplicative inverse, you are correct. Next, we're going to look at a couple examples of using these properties. So in our first, we have this expression, and we want to simplify it or to evaluate it, and we want to give a reason for each step that we do. So if I start with order of operations, thinking about that, I'm going to need to look at this part first. So I need to do 4 minus 3. So my next thing is going to be replacing this with its difference. So 4 minus 3 is 1. So my new expression will look like this. And that reason is going to be substitution. So substitution says that 4 minus 3 is 1, so I can replace 4 minus 3 with 1. So substitution. It didn't match any of my other properties, so I get to use substitution. Alright, so going back to order of operations, the next thing I would need to do is multiplication. So I'll do this multiplication because it's on the left. So 7 times 1 is 7. That does meet one of my magical properties. So 7 times 1 is 7. The property that matches, I multiplied by something and got the same number out. So that's an identity, and this is the multiplicative identity. So now let me write out what I have left. So I did 7 times 1 is 7, plus 5 times 5 times 1/5. Okay, so multiplication again, my next step is going to be here, and I have 5 times 1/5. So this is 5 over 1 times 1 over 5. And so whenever I multiply those together, that's another special identity because those are two reciprocals being multiplied by each other. So 5 over 1 times 1 over 5 will give me 1. So the reason for that is going to be my multiplicative inverse. So 5 over 1 times 1 over 5 equals 1. So now let's write in the other stuff. 7 minus 1 plus 1 is my next thing I need to look at. So now I have addition and subtraction from left to right. I'll go here next. 7 minus 1 gives me 6. That doesn't match any of my other properties, so this reason is going to be substitution. We're going to provide our reasoning. So 7 minus 1 is 6. So whenever we see a 7 minus 1, we can replace it with a 6. Whoops. Copy this down. And our final thing, we have 6 plus 1, and that is 7. So 6 plus 1 is 7. That didn't match any of our special properties, so this is substitution. So that's our final step for this problem. Just 3 more properties to go as we move forward. So now we're going to look at properties that work for addition and multiplication. So these properties that work for addition and multiplication begin with the commutative property. So I know we've already talked about the commutative property a little bit this year. So the commutative property says the order in which you add or multiply numbers does not change their sum or product. So we can move them around a little bit. So commutative starts with that word commute, which means to move. So what we can do is we can say a plus b is the same as b plus a, and we can move things around and add them in any order, and that also works for multiplication. The next property is the associative property. So that means the way you group numbers when adding or multiplying doesn't change their sum or product. So if I have 3 numbers that I'm adding, and I choose to add the first 2 or add the last 2 together, it doesn't matter. It's going to be the same. Same thing with multiplication. So just make sure whenever you're doing this, you're only working with addition or multiplication. So we have some examples down in the bottom. So let's look at those. So first we have 3 plus 5 plus 7. So we can start with 3 plus 5, which is 8, and 8 plus 7 gives me 15. Or I could have done 5 plus 7 first, got 12. 12 plus 3 is also 15. In the multiplication example, I can change it around whichever way I want. So 2 times 4 is 8. 8 times 6 is going to be 48. Or I could have done 4 times 6, which is 24. 24 times 2, which is also 48. So the order or the way I group them does not matter. So here's our first example. We have some addition, and we want to use our addition properties to work out this problem. So let's look at these numbers. Let's first write out our problem as it's shown to us. And then I want to look at ways that I can group it to make it a little bit easier on me. So what I see is that I have a 0.75 and a 0.25, and I know that those can make one whole. So I want to group those together. So before I can group them, I have to move them. So first I'm going to move them. And that just flips the order of those middle two terms. So now, this is the commutative property. And since we're doing addition here, we're going to say commutative property of addition. Now I can take these and group them together. So 6.75 plus 23.25. Group those. And then group my other two, 14 even plus 20.50. So the way these are written, it really makes me think of money. Since I grouped them, I put parentheses around them. This is the associative property, and we'll throw in that addition sign as well. So since we had 75 and 25, and like I said, it makes me think of money, that's going to make a whole, so we can just think of this as 6 plus 23 plus 1. So 6 plus 23 plus 1 is going to be 30. And here we have 0 and 50 behind the decimal point, so 0 cents plus 50 cents, 14 plus 20, that's going to be 34.50. And I can add these things together, and that will give me 64.50. So on this one, these last two steps are both substitution. They didn't meet any of our other magical properties. So remember, if it's all multiplication, we can move them around. We can do it in whatever order we want to. So for this one, let's look at how we can move them around. So first thing I see is I see a 5. So I want to group a 5 with a whole number. Let's group it with this 2 because I know that 5 times 2 is 10. That will make whatever I'm working with here a lot easier. So first I'm going to reorder it. So I'll have 5 times 2 times 7 times 4, and that is the commutative property. And this is of multiplication. We can use our X times sign for this one. Next, I'm going to group them. So I really wanted to do this 5 times 2 first. So that's going to be my associative property of multiplication. So 5 times 2 is 10, and 7 times 4 is 28. That was substitution. And now that I'm working with 10, I know that 10 times any number just adds a 0 to the end, so this will be 280. And that's also substitution. So now the property we have to go over is the distributive property. So the distributive property says multiplication can be distributed over addition or subtraction. So this only works when there's a plus sign or a minus sign inside the parentheses. If there is, then we can multiply both things inside parentheses by the number that's outside, and it'll stay equal. So you can see that A times the sum of B and C is AB plus AC, or the number can be hidden out back, and it works the same way. So we just multiply and keep that sign in between, or apply it to the number afterwards. So this gets really important when we start working with negatives. So here we have two examples. Let's start with the one on the left. So for this one, I have 7 times 3w minus 5. So distributive property says that I can multiply over addition or subtraction. So this would be 7 times 3w. I'm multiplying over that, so now I have 7 times 5. 7 times 3w would give me 21w, and 7 times 5 is 35. I can't simplify this anymore, so this is my final expression. On this next example, we have 3 terms, and this is a square and this one's not, so this is actually in simplest form. We're going to distribute over that. That just means I distribute over addition and subtraction here. So I have 4 times 6v squared distributed over the addition. So 4 times v distributed over the subtraction. So 4 times 3 here. And now I can simplify 4 times 6v. It only applies to the coefficient number out front, so that's 24v squared. 4 times v is 4v, and 4 times 3 is 12. This is in simplest form. This one has a 2 and this one doesn't, so they can't combine. There is our simplest form. So take a second to look at the your turn questions and quickly work through those. The toughest part is going to be this negative, so watch out when you're distributing this negative.